I'm Brad Culberson. I'm a field TTO at Snowflake. I focus on data applications, so I work with a lot of customers, helping building applications directly on top of Snowflake.
Yeah, and hi guys, I'm Dmytro. I'm based in London, also part of the field CTO office, looking after performance solutions predominantly. So today we want to, first of all, super excited to have opened this first breakout sessions of the summit. And we want to split it in two parts. We want to talk a little bit about the use cases, different options available for you to do the fast data load into Snowflake, and then also spend some time demonstrating you by examples of what are the important options and characteristics you need to bear in mind choosing one option or another. Right, I would apologize in advance for my voice. Unfortunately, I lost it a bit, and kudos to Brad, who kindly agreed to cover the majority of the talk track later on. I'm just going to spend a couple of minutes to talk about the important milestones that we at Snowflake bear in mind, or suggest customers to bear in mind when you're thinking about your data pipeline. Obviously, you start the timeline from the moment the event was created, right? And an event in this context could be anything from your user adding the item to your shopping cart to a change that happened in your upstream database that you want to integrate into your analytical landscape. Then from the moment event created, we also often highlight the time it become available to your data platform, right? That's important. Snowflake is a cloud solution. You need to make data available for it to work with it. And then obviously data needs to be transformed into the insight with all the cleansing transformation involved to make it action ready. And from functional perspective, this translates to three high-level stages that I'm going to use later on in a few subsequent slides as a framework. So we're going to talk about the integrate, which is, by the way, going to be the key focus of today's presentation, right? Fast data ingest into Snowflake. But there is also the processing that really matters from options and design perspective. And last but definitely not least is the use of the results. So you're going to hear us talking many times, quite a lot in terms of a decision tree on using one option, one building primitive versus another one. Really depend on what do you do with the insight you've generated, right? That drives the different options, that drive the different latency and functional and non-functional characteristics. With that, let's have a look on some of the options, right? And we're going to start with something fairly simple that I got to say majority of my customers, including myself, who just started working with Snowflake, was playing around first, because that's, I think, something that everybody could relate to. So on the left, you have, again, still the same pattern and color code. You have integration orange, blue for transformations, and purple for use of results. And then you have that little orange circle on the left indicating that the event being created. But let's imagine we change something in the upstream system, and in one case that could be resulting in a file being produced upstream that you want to bring in your analytical landscape. You upload it into a stage, which, as you all know, is one of the cloud buckets, whether it's S3, Blob Store, Google Cloud Storage, or you may have an event enqueued into your topic in the Kafka message bus. And then from there on, you have a data in stage, and then again, this is just one of the patterns. You have asynchronous load, synchronous processing, and here you got your results ready in purple circle to be consumed. I deliberately blurred out the right-hand side with the right answer, what the technical part of it is. But I'm sure for anyone who used Snowflake even a little bit, you came across that it's a copy command or our stored procedures, right? Something that customers very often start with. And just on synchronous and asynchronous, I hope we're all on the same page in terms of the difference, right? Synchronous, super simple to engineer. You have one script or one orchestrator process that controls the execution, and one command is starting as soon as the previous one finished, right? Very simple from a design and build perspective. But also what we noticed, there is a big benefit in leveraging some of the serverless processes, some of the serverless capabilities that Snowflake provides. And as a result, tapping into the asynchronous design pattern, right? So following this diagram, this approach, you have the data still in stage and formed with a bunch of files that you haven't seen yet, and you want to load into Snowflake. And you may invoke the asynchronous process to load it, and another asynchronous process or processes to transform it into insights-ready data set. And in terms of the right answer, yep, it is Snowpipe. And it's also about the framework of transforming data. And this is where you already have a little fork. And what do you prefer to do? Do you want to follow the imperative transformation patterns with streams and tasks? Or as you heard during the keynote, we are doubling down on declarative definition of your transformations using dynamic tables. And then the patterns that we've seen also appearing on the top, again, this is never going to be one slide describing all possible permutations, but something that we've seen in the field quite a few times, where you really need to deliver the output, the transformed data set as soon as it's possibly or technically possible. You can perform it on the fly as well. And with Snowflake, while this means that you would be transforming before you optimize it into Snowflake platform, but you can get the data as soon as it's landed in the stage, right? As soon as it's landed in one of the cloud buckets. Again, from technical perspective, this could be a view created and pointed to your stage. It could be external tables, or it could be materialized views to optimize the access to it. All this works really well. And again, this is something that we have in GA. As you just heard from the keynote, there is a big, I think, interest and a big attention for Snowflake to support the true streaming use cases, delivering near real-time insights to your consumers. Hence, Snowpipe Streaming is one of the fantastic capabilities that we are super excited to get on board. So Snowpipe Streaming comes in a few different flavors. At the core, it is Snowpipe Streaming Ingest SDK, which is also integrated in our new version of Kafka Connector. And as you would notice here, the big difference is in terms of a data is visible stage. At this point in time, you would have data in the table available for you to query and work with it as soon as the integration happens. So pretty much at the end of the streaming pipeline SDK or offloading it from Kafka, you already have it in the table. And then you have the asynchronous optimization and asynchronous processing to get it to, again, in action-ready state. And on that, from technical perspective, you have quite a few new primitives. Again, Snowpipe Streaming, dynamic tables, if you can afford that initial lag that dynamic tables are bringing in. But also, you could be using materialized views, or we also doubling down on reducing the latency for the tasks. Something that engineering team is still working on and hopefully going to soon get in the preview is a trigger task allowing you to initiate the processing of the task as soon as there is a data available in the stream without waiting for the next schedule. And I think that list wouldn't be complete if we wouldn't talk about one more option. And I think the diagram speaks of itself, right? Not saying which one is better, but if you don't need to build ETL, if you don't need to integrate data as a consumer side, the life is getting much easier. I don't want to say there is no work involved at all. No, of course, as a consumer, you need to integrate it and align it. But the fact that you as a consumer are getting the data available as soon as there is a change happening upstream and you can clearly identify what's new, I think is what making the data cloud possible. Right, with that, I just want to also show you a slightly different angle to look at those capabilities, right? Brett and I were thinking how to divide them, and we ended up with these two high-level buckets. You have the approaches where you want to register metadata while the data is still sitting outside of Snowflake. And hence, as we spoke, it could be a view on stage, on the fly, figuring out which files are available, which could be selectively applied. If you want to take it next step further from performance perspective, you can leverage additional knowledge about the structure of your bucket using external tables on the blob store. You can leverage our integration with open table formats. You have Iceberg, you have Delta, you have integration with Hive. But then if you really feel like the data you're dealing with is going to be reused by not just a one-off experiment, but rather be adopted widely in the organization, it's really, really wise to ingest and optimize, right? And on that front, use case-wise, it's quite hard to beat the level of control and scalabilities that you can achieve with bulk data import scenarios using the copy command and insert, having ultimate control of how much compute you have. For a little bit less predictable workloads or optimization, and again, simplifying your architecture, your orchestration pipeline, you can leverage serverless ingest using Snowpipe batch, combination of maybe serverless streams and tasks. When you have data available in Kafka, you now have two choices between Snowpipe batch, let's call it this way, like working with the files with preemptive optimization, or Snowpipe streaming with a deferred optimization. And of course, we have a combination of those register metadata and optimize in parallel by having a materialized view pointed to your external table, or periodically copying the data that you've already addressed in the external table. With that, before I completely lose the rest of my voice, I'm going to hand it over to Brad to walk you through some examples.
Thanks, Dmytro. So I'm going to take on the rest of the presentation. So I haven't really prepared these super well, but I'm going to try to cover as best I can. Really, when we talked about this session, we work with customers every day, and we see this as a really hard decision process for customers. Snowflake has so many different ways of ingesting data, and we divided this into different use cases. And I think when you start classifying use cases, it'll start becoming more intuitive to you of how to import those. The one we're focusing on for the rest of this presentation today that Dmytro talked about is this copy insert. We're going to show that, or at least show you the behavior of that. We're going to show tasks in that serverless ingest piece, and we're going to show you some of the new Kafka pieces. So how does the Snowpipe batch perform? How does streaming work? And then I also have some information around the streaming SDK also. If you want to follow this later, we've made all this available on our quick starts. So look for our quick starts on snowflake.com. It's actually quickstarts.snowflake.com. Go to Tour of Ingest. And we went through, we actually created code for you, and we go through all of the different ways that we're going to demo today. And we have a data generator that generates a bunch of data that we think represents a real world use case. Then it ingests it all these different ways, and it shows you the code, the complexity. You can time it, you can get credit consumption numbers, and you'll see us go through that today of what we found when we were comparing all these different ones. And often customers say, should you do this or that? And it is dependent on the shape of the data, what your expectations are. If there was one, we wouldn't have many, many different ways of ingesting it. But we just wanted to show you where things go well and also where the bear traps are. So we also show a few cases where it actually went quite wrong for us and what you really need to look out for while you're doing this. So this use case we have that you'll see in that quick start, we're very themed around snow. So it's lift tickets, and you're going to a ski resort, and you're getting a bunch of lift tickets going through a system. And you can imagine this being like the counter you go to buy your tickets. And all this is streaming data flowing through their infrastructure. So we have this test generator. All of that will be evaluated in all these different ingest patterns to show you how quickly it showed up, how expensive it was, and then what that throughput was. And if you guys want to, there's the URL that I mentioned. The first one, and as Dmytro said at the very, very beginning, customers usually start with using a warehouse doing copy intos. And they usually upload data. They just do a basic copy into. What's really that comes up very, very often as case is these clusters are very often underutilized. And in the demo and in that code base, you'll see it's waiting for some tickets to come in. It's aggregating a bunch of them. I wait until I get enough that it's interesting, and then I upload that file, and then I do a copy into. If you think about that, we've got a warehouse running 24 hours a day, that's taking these occasional copy into commands. So it's vastly underutilized. And that's why that cost per terabyte is ridiculous. Like you should never have a system running at that number. But the reason it was doing this is because it was just sitting idle, waiting for me to upload a file and doing a copy into. The way to optimize this, if you had infinite time, would be to try to ramp up the concurrency, get some more files landing, want more data. Like I'm sure ski resorts would love to just have more people buying tickets. There's also a data shape problem here of there may just not be enough data flowing to actually fully utilize an extra small warehouse. And then you could never keep this in an optimized state. So it's worth thinking through that velocity of data. In this case, in all of these, we uploaded 100 million records. It was around 37 gigabytes. You'll see that change based on compression. This is a random data generator. In this case, you'll see the target files end up being 34 megabytes. So we tried to get to well-sized files here. We got to 100 megabytes of data. It was 34 megabytes compressed. They were quite efficient loading, but the warehouse running 24/7 really hit us a penalty for the efficiency. Here's actual code that was running here. You can see we used the data frame or Pandas data frames to actually do this write table. And then it did a put, and then it did a copy into. Quite easy, but also quite inefficient in this specific use case because of the underutilization. The next step we often will see is that jumping to serverless. So in that case, well, if you have underutilized warehouses, it might be nice to actually maybe do that with a serverless infrastructure. And this is where Snowpipe gained a lot of popularity. And this really allows us to use something like a serverless technology. In this code base, I use a serverless task to actually optimize this. So the serverless task is actually doing that copy into, so we're billing it by the second. I actually didn't use Snowpipe. I'm just using the task framework. Something nice about this is allow you to copy a bunch of files. So occasionally customers have difficulty like getting to well-sized files. In this case, we did create 100 meg files to give this use case a very good chance of success. But if you do have cases where you have a bunch of tiny files, this is a very good way to repair it quickly. So you could have that task run once a minute, go out and grab all the data that showed up in the last minute, one serverless task running for seconds, hopefully, that ingests all that data and lands it in Snowflake efficiently. You can see here, the results were dramatic here. It's 5 times less expensive. Credit consumption went down dramatically here. Time to visibility was still about a minute. So actually, there wasn't any real delay with the visibility time here. And really, in this case, what most of that visibility time was us just waiting for enough tickets to come in to actually upload the file to do the copy into. So this could actually be quite fast. That is a copy into, so it's using our infrastructure to be able to do that. Quite efficient at well-sized files. But this can be complicated because now you're managing a serverless task. You're running this asynchronously. It's running every minute or whatever you're scheduling it to be. So sometimes this isn't ideal. There's the code for it. You can see it's actually pretty basic. We're just running a serverless task, running a copy into, and the client's actually just uploading files. So it's usually pretty quick to refactor those. So if you do have code bases that you were uploading files and using a warehouse to copy into, this is very easy, iterative approach to say, oh, that's underutilized, let me switch to something else, because you can probably keep all your existing uploading exactly the way it is, and then just allow the ingest to be a little bit more efficient by being billed by seconds. We're going to jump over to Kafka a little bit, and this just depends on your use case. We see a lot of customers using Kafka as a message bus today, so we wanted to talk about it. And the first use case that we'll talk to is the one that's been available for the longest. If you're using Kafka today, you're probably having it in batch mode. We called this Snowpipe mode before. This also allows a certain amount of data to accumulate. We wait until we have whatever the configure value is for how big the file is. Then we automatically upload that for you inside of Kafka, and then we allow Snowpipe to ingest that. So in this one, that can have some decent amount of delays because you're waiting for your data to accumulate as well to get to a well-sized file. And then also you're waiting for Snowpipe to come through asynchronously and then load that into your destination. Those are all written in R format immediately into our data store. That's a differentiation that we'll make with streaming. So when we do that Snowpipe load, we're writing it in R format directly into the table in that asynchronous process. But that means that visibility, so when the data actually becomes available is delayed based on how long did it take in Kafka to get that data to accumulate to a well-sized file, as well as how long did it take Snowpipe, that job system, to actually pick it up and then ingest it. So a lot of customers are trying to push that latency number down. So that's one of the main reasons why we worked on streaming. And we've embedded that streaming SDK now inside of Kafka. So this is a very easy upgrade for you. You can literally just upgrade your Kafka connector version for Snowflake, change one configuration line to say you want to use streaming, and then this will work. The real benefit to this is that faster visibility. And it's doing that by having the client upload a file directly to Snowflake that we register in metadata without doing any conversion into our internal proprietary format. So that visibility time gets dramatically shorter. I'll talk about it a little bit later, but that time to visibility you can get extremely, extremely short. In the demo I had prepared, we had that, it was going between 800 milliseconds and 1.2 seconds from when the event was generated and when it was landed and queryable and available to queries coming in. So now we're really looking at this 1 second, sub-second query for a lot of these that we're testing. Just because they're not written synchronously to our format doesn't mean it doesn't happen later, and it does. So eventually we have a merge routine that comes in later, merges all those together, gets them well-sized, lands it into our columnar format. And that's really the credits that we're billing inside of the Kafka streaming. The largest number you'll see is from that async merge process that happens later to get it into our format. The schematization is also optional in the new connector, which I think is phenomenal. A lot of customers are landing data in variants today, and then their first transformation process is getting it like split out into the columns they want. So it's now built into the Kafka connector to actually do that for you. The SDK also does this, so the demo also showed that, but whenever you actually push data into the SDK, it can already be columnarized and you can have all your columns defined. You can upload that and it lands directly into a structured table. There's no variance in there at all unless you choose there to be. So what does this look like in Snowpipe mode? So we want to compare this against what we had available. So this is the batch operation where we're uploading 100 megabytes at a time. The biggest challenge I had when I was working both as a customer and as Snowflake, helping solve this for efficiency, we mention it all the time, trying to get to well-sized files, but it's extremely hard. Like every time I say that, I know it's very difficult for you. Not all data shapes can even get you to 100 megabytes in your SLO. Like ideally, yeah, you could get 100 megabytes in time that your customers expect data to arrive. That's not always even possible. And even if it's possible, it might be pretty hard on the engineering side to do that. So, but if you want to give this a fair chance, you do want to get to 100 meg files at least. There's many things that affect that. So like your number of Kafka partitions affect that. So every partition is written to a separate file inside of our consumer. So if you only have 100 megabytes coming in every minute and you have 2 partitions, you're already at a difficult thing there to get that to a minute because now you're going to have 50 megabyte files written every minute. So you immediately would have to go to 2 minutes to get to 100 megabyte files on 2 partitions. That's difficult. Like I could say, oh, it'd be really nice if you changed your partition count, but there's probably all kinds of different consumers on that Kafka cluster. There's probably downstream consequences of changing the way Kafka is configured. So it's not always a configuration thing you can change. This can go quite bad when customers really over provision it. So sometimes I'll come in and there's not much data flowing and there's many partitions. What happens there is if you look at the file sizes coming into the Kafka connector, you'll see like 1K files, 1 meg files. Your costs are going to go up by orders of magnitude if you have those kinds of file sizes in there. So it gets extremely inefficient today when you're running this. It's also inefficient in Snowpipe. The real issue there is we're loading tiny files. There's a lot of fixed overhead of talking to S3. We're provisioning a warehouse and allocating it to you to load a tiny file with large latency to S3. And then we have to build that. And the challenge there is it's not efficient, right? So how do we get this to be more efficient? Dropping the partition counts would help if possible. Another way would be try to work with the product team and try to get the SLOs to be longer. So can we add more delay? If we can wait more minutes, you can get the larger files. But that's not also always possible. So there's definitely situations where we had with this that we were in a difficult position where we had undersized files because we couldn't change Kafka, we couldn't change the file sizes that were dropping, and the SLO was what it was, right? What's really nice about this is compatible with all the different Kafka versions that you can run. It's actually quite easy to set up. If you have Kafka in your infrastructure, I would definitely suggest checking out our connectors. And it also transitions you very, very well to streaming later. So it's something worth going in. In the quick start guide, I go through, and you'll see this if you do go through that. I set up an MSK cluster inside of the test. In the quick start, I use red pandas locally, so you can see we have compatibility with all of them. These things do actually use quite a bit of CPU and memory to both compress and do the encryption and batch these files up. So make sure you do size them appropriately. And I used MSK for the numbers I'm going to show you in the next slide. That's Amazon's managed Kafka Connect solution. In that, I was using 8 CPUs and then had to auto scale up to 10 of that. So it could have been up to 80 CPUs through max load. And I was just running 2 brokers in this case. In this one, if you're looking at billing things, there's multiple pieces here. You think through the Amazon cost. You do have MSK running in there. Probably in this case, you may have other infrastructure for the Connect cost. In Snowflake, you have the cost of Snowpipe that's actually ingesting those files. And there's a minor amount of credits consumed in cloud services. Some customers ignore those. You may or may not be able to ignore those based on how large they are. But I included them in the next slide, so they are fully included. And I didn't assume 10% was comped, so it actually includes them at all times. In Snowpipe mode, you also see a cost per terabyte. That's pretty bad compared to those numbers we had earlier. I think we were down to low teens on some of those other solutions. And the reason this is actually fairly high is due to those file sizes. See, we've got 7 megabyte files coming in. So even though I tried to get to well-sized files, I had it configured to get to well-sized files, what was happening here is actually with the 60-second flush and the message rates, I was still not getting to good well-sized files. So I configured Kafka saying, hey, I want 100 megabytes, but I also wanted a minute. And that then forces a flushing function here that makes it so we're getting underutilized files or undersized files. So in this one, what I changed on this slide, so I switched the partition counts. So we went from this one, we reduced the partition counts. We also increased the buffer flush time to 2 minutes. So we were like, okay, we really need to get larger files. So what do? We need to hopefully get bigger. You can see the previous one was 7 megs. I got up to 24 megs. So we were able to get it to be 3.5 times bigger. That's great. It's going to be more efficient. You can see our cost plummeted. So we were able to get the larger files. Costs are now down to the teens, which is what we were seeing earlier. And that was done just by changing the flush time. You can also change the partitions or other thresholds to do that also. But this file count's really important to look at if you're trying to get to efficient operability. The reason we're pointing this out, it's not around fast ingest. We're going to lead this into why is streaming better? And what it ends up being is with streaming, we can actually do this fast ingest without all of this complexity of all this configuration. And all of this file sizing stuff, I mean, I can't explain the number of hours and weeks I've spent trying to get customers to get this optimized well. This is hard. And this is way too much effort for you to be able to hit this. And we were like, this has to be easier. What can we do to make this easier? And I don't want to ever have to say, let's adjust all these configuration parameters to get to 100 megabytes again. So Snowpipe Streaming is solving this. It makes it dramatically simpler. And what's nice is you'll see the cost competitiveness of it is incredible. So in this, I took that exact same code. I literally made one configuration change. The client's behaving completely differently after I changed that. So it's no longer uploading this file to be queued by Snowpipe. It's now creating a local file and formatting it appropriately. It's still micro-batching a set of records, uploading those to Snowflake. The nice thing about this is they can be very small files. So if I see a customer using Snowpipe Streaming, and if you use Snowpipe Streaming, and I see 1K files, I don't start sweating and freaking out on the phone, worried about what it's going to look like. It's exactly what it's designed for. Later on, the merge operation is going to combine all of those and make it efficient for Snowflake. Short term, it's just going to work. So we changed the flush time in a lot of these cases with customers because we're no longer fixed where we're like, oh, we really need to get to 100 megabytes. Right now in batch mode, I'll work very, very hard to try to get to 100 megs. In streaming, it's what's your SLO? How quickly do you want to get the data there? And I'm no longer stressed about do we get to 100 megabytes or not. So you can set these flush times quite low. If you look at most of our demos that we're showing here, as well as the things we're doing online, you'll see us using 5 seconds, 10 seconds frequently. Very, very low numbers. You would have almost never seen us running the Snowpipe systems in 5-second flushes. This is also as compatible as the other ones. So very, very compatible, working right now, very, very stable. This is a public preview feature, but so far all the customers that are using it have been ecstatic on the reliability of it. So that's all you have to do. It's literally inside of the configuration file. You change the method, and you can adjust the flush time if you want to. Highly suggest you have pre-production environments today. Go out and start playing with this. and watch your service credit consumption change. I haven't seen a case yet that customers haven't saved money. The only way that they're cost competitive, and you'll see the comparison at the very, very end, is if you got to perfect file sizes in batch mode, they're basically the same cost. How often do I see perfectly sized files in Kafka or Snowpipe Streaming? It's almost zero. Usually there's some tail off peak or somewhere where that's not happening. Billing is based on cloud service credits. There's this asynchronous job that's doing that merge. That's billed by the second. So these are all happening in serverless compute there. And you can grab all the information for that inside an information schema. So we're hitting mid-teens on this one for this test. If you do have, like, everybody usually tells me, Brad, like, I don't trust your $15 number. Please use please use that tour of ingest, change the data generator for data that looks like yours, and just run the same code. So you can go out and edit the data generator, run the same thing. You can get your exact numbers for this. And that isn't the exact number for everybody. It depends on compression. It depends on your data shape. It depends on many things. We're just doing this for comparison. And when you see the comparison at the end, you'll see how they line up. And these all use the same data set, which is nice. Time to visibility here. All the ones we talked about previously were all like in minutes. In this one, this was 10 seconds immediately with the flush rate of 10 seconds with the flush rate of 10 seconds. So we've shaved minutes out of this. And it's also very easy to continue to lower that to get down even faster. And we're in the mid-teens there for cost per terabyte. So that's really great if you're using Kafka, but that isn't always possible. And I definitely would not suggest, if you're not using Kafka today, please don't go and try to take the overhead of running Kafka just to get that. So we have an SDK. The SDK we use for the Kafka connector, you can use yourself in Java, and you can do the exact same code we're doing. What's really nice about this, you can bolt this into any system you have. So if you're using Kinesis or Google PubSub, or your application may already have a spot where you're already writing these files out and you're already doing these copy statements, you can plug our SDK in at that point and then start sending the data directly into Snowflake. Demo I cannot show you today. It is unfortunate. Please check out the tour of ingest. I'll explain what it was doing. So in the quick start, it does exactly the same thing. So you can run this on your own laptop. This was running inside of Amazon. It's running on MSK, and it is running a Java application project that is taking standard in. It's grabbing JSON data from standard in that's coming from the data generator. It automatically uploads that data into Snowflake. The end-to-end time from when I generated data and it was showing up in Snowflake ranged from 800 milliseconds to 1.2 seconds in this scenario. And that was with, I think I had a 5-second flush on there, but actually it was flushing due to the record count instead of that. So it's quite impressive. I definitely suggest you to go try to get your hands on it. I think that tour of ingest is a very fast way for you to have all of the code running and to see it working live on your laptop, which is incredible. And I think like the real takeaway I want to have for you today, hopefully leaving here, is this ability to lower the visibility. And historically, this was always a trade-off. It was always, oh, you'll have to spend more money to get this faster visibility. It was always, oh, like you don't have enough data flowing, or it's more complicated. And we've removed all of that complexity now with streaming. So I'm super excited for it. There's the data grid. And it really shows this cost per terabyte and how it can go both good and as well as it can kind of go rogue. And in this case, the $100 per terabyte is being fairly negative towards bulk data import because I didn't give it a fair chance. But also, it's very common for customers not getting to good size files. If you do tune that for well-sized files, you will get down into the mid-teens, like you saw with the Kafka and Snowpipe. So it can be cost competitive, but also it's complicated. And in many cases, you're just better off moving to streaming, and then you also get the benefit of lower latencies. The first time I ran this, I actually reached out to product and I told them I thought the billing system was broken because I assumed Snowpipe Streaming would have to be more expensive than Snowpipe because I've been using Snowpipe for years, and in most cases, when we line up ourselves against other solutions, we've almost always been cheaper than almost any other thing that was out there. When we were using Snowpipe, the first time I used streaming, it was actually as cheap as Snowpipe or a little bit cheaper. And I was like, wait, we can't deliver something with lower latency as well as less. That didn't make sense to me. But it's really showing the mechanical efficiency we've been able to drive with changing the way those files are landing and the way we're using the metadata. So if you have a takeaway, I definitely suggest screenshotting this. This is basically a full decision tree. So if you're at home and you're like, Brad, you've mentioned all these different ways of ingesting data, and it's so complicated, I don't know how to pick the right one. You start at the top and you start going through the decision tree, and we'll take you in the right direction. And in this case, it talks about like, are you using, do you already have data that's streaming through your systems? Is it not streaming? And automatically goes through, is this already in a message bus system? If it's in a message bus system, we take you down into, if it's Kafka, you can use our Kafka connector. If it's not Kafka, can you use our Java SDK to do that? If not, if you can allow for some latency, you can start going into using Firehose and using Snowpipe for ingest. And those systems are really, really good if you can get to well-sized files. And the bottom section here, like we still have probably 90% of the data comes into Snowflake comes in through something like this. It's like a Firehose or well-sized files using Snowpipe. Extremely efficient, but we're seeing minutes of delay in those, right? And that's not always okay for all use cases. So I'm super excited about serverless. Hopefully this will help you. I think, while I love the power of all these different methods on Snowflake, I think the challenge for you is really being able to navigate these quickly and making the right decisions. If you're looking for more resources, we've included a few links up here for you. The documentation for Snowpipe Streaming is available to you. It is public, so you can go home and play with this right now, or you can go and play with it after the session. It's pretty awesome, very stable. The SDK for Snowflake ingest is also available. There's some good documentation out there. The code is also quite simple. If you look at my quick start, I think my Java app that's doing this is less than like 50 lines of Java. So some customers, like when we started with this talk around streaming ingest, they were like, Brad, that's great, but I'm not a Java shop. And then I was like, here's a program that literally takes standard in and just sends it to Snowflake. Could you run this, right? And it's simple enough, actually. I do think I would look at it even if you don't have a lot of Java expertise, because you can build small services in your organization to still leverage it. You may already have Kafka, which you get it for free if you're using Kafka in there. I've had a few customers build REST APIs in their internal systems that are using the streaming SDK. So one team builds like Java endpoints, and then everybody else starts using those. So I think you'll see more of that coming out. We'll also continue to publish more quick starts as more things become available. And also, as I mentioned earlier, I don't want you to ever trust my dollar numbers, because that was a fairly invented case that I just came up with that was interesting for me. But you know the shape of your data, and the shape of your data does matter. How well your data compresses matters a lot. So you'll be able to go in there. You can change that data generator very, very easily, and you can shove your data straight through the Java that application I wrote and upload it directly into a table. And it lands schematized, which I also love. I think, while I like the flexibility of variants, I also love the queryability of structured data. So you can choose your choice there. And in the quick start, I actually do both. So the quick start actually lands a few fields in structured format and then a few in variant. We appreciate your time today. Thanks.
Thank you.